right, this is CS50, and this is sadly the end, where we wrap up the semester and take a look back at the past several weeks, give you a look at what's ahead in the next several weeks, and then really the next several years, how you can sort of go on beyond CS50 with the proverbial training wheels now completely off, and so that even without things like CS50 IDE and Check 50 and Help 50 and other such tools, you actually feel like you can apply all of these lessons learned and all of these tools you've experienced in CS50 to your own Macs and PCs in the real world. But I thought it would be perhaps helpful or reassuring, especially on the heels of so many problem sets, some of them especially challenging, and a recent quiz here on campus, to just think back at this tenet here. And we do mean this, and realize if you're a little uneasy as to what remains in store over the next few weeks, that what ultimately matters in this course is not so much where you end up relative to your classmates, but where you end up in week 10, which is today, relative to yourself in week 0 some 10 weeks ago. So that was just a bold claim, a pie in the sky back then, but you've made it to this now finish line where all that remains is that one final milestone where there's no specification, you're not told what to do, but you get to design and implement yourself. And consider, too, over the past several weeks, odds are many of you never really felt like you got your footing, like ever just as you started to grasp something, we sort of pulled the rug out from under you or kind of asked you to take another step up cognitively and actually understand something new. Well, that's very much the design of this, right? I was trying to think of metaphors yesterday, and if you're into like weightlifting or such, which I'm not, I suppose the analog here might be you're sort of, doing your weightlifting, and someone keeps putting more and more weight on the thing as you get better and better, and so you never actually necessarily feel like you're making progress because it never gets any easier, but that's just because the weight on either end is, so I'm told, is getting added to and added to. And I do mean that more academically here too, is that with every passing week did we start to hope that you were reasonably comfortable with what was in the past so that we could lead you further along in that journey. And perhaps most stark is the fact that 10 weeks ago, many of you probably found this difficult, right? It's probably not all that distant in memory how many minutes or hours or a few days that it actually took just to get Mario, so to speak, and Mario's not even in the picture, to just ascend this kind of pyramid by using hashtags. And honestly, just a week ago, did you all build this, CS50 Finance, which had a backend implemented in Python, generating HTML and CSS dynamically, that was talking to a front end that itself was built with client-side languages like HTML and CSS and JavaScript, talking meanwhile to an API via HTTP that brought in data from a third-party source. Like, that's where you now are. And so even if you don't feel 100% like you could build this from scratch, and that's fine. Indeed, what many students do for their final project is start with something like PSET 8, tear out all the finance-specific stuff, and then start to add their own thoughts and ideas and their own code. Notice just what the delta truly is. And that's what we mean by that delta between week 0 and week 10. I received just this past week, actually, an email from one of your classmates who I thought was wonderfully reflective on what their experience had been like, and quite consistent with this idea of not quite ever getting their footing, wrote this. Besides learning the new material, I felt that I started to be more comfortable with being uncomfortable and being OK with working towards building a skill rather than getting the right answer. Right? This is the kind of quote that you kind of see in like a Harvard brochure or whatnot. But it's like, it really is true. This idea of being being comfortable, being uncomfortable is very much the case. And honestly, you're never really going to get your footing in this world. Because honestly, everything we just taught this past semester is going to evolve starting tomorrow and in the years to come. But hopefully what we've done in the class by choosing certain languages, some of the most foundational like C and SQL and now Python, even as those languages evolve themselves or become less used, the principles of memory management and data structures and trade-offs and abstraction and encapsulation, all of those principles, like those aren't going away. And that's the advantage, I think, of starting from the so-called ground up, right? It wasn't that long ago we were talking about zeros and ones. So you're not just software engineers, you're computer scientists or budding computer scientists, because you have those mental models that can then be applied to any new technologies or domains that are down the road. And if it's reassuring, too, even I feel this way. Like, I don't feel like I've mastered CS50 or all of the material therein. I kind of feel like that graph that we drew that was that green curved line where, like, fortunately, I'm always making some forward progress, but I'm never actually reaching the peak of anything because there's always something new to learn. And it's scary, too. And in fact, the most relevant instance of being comfortable being uncomfortable, or maybe in my case being uncomfortable, was just a few years ago. For many years, CS50 had used a language called PHP for the web programming portion of the course. And eventually, we as the staff decided, it's time to transition to Python, which has a number of upsides, among them the applicability in the real world. It can be used more effectively for command line programs, data science, data analytics, and it just felt like it was time. The one catch was I didn't know Python. And so this sounded like a wonderful idea, sort of philosophically, that summer. Yes, we shall teach Python this fall. Then October came around, and I realized, oh, Python's coming up in a week or two. We should probably, we, meaning I, should probably go learn Python. And so that entire semester, was I learning, and were we paving the road as we went? And I swear, if you look back at the videos from just a few years ago, the Python lecture was like the longest lecture ever we have, because I was so damn determined to prove to everyone that I knew Python by that point in the semester. So perhaps overcompensating a little bit. But this is just to reassure that none of us, even the smartest of your teaching fellows and CAs whom you interacted with this year and myself, like none of us ever stop learning or stop being a little uncomfortable with this stuff. So even if you feel like, wow, I didn't quite absorb everything this semester, like you weren't ever going to, because we never did either. So take that to heart, if you would. Before we forge ahead, oh, in fact, I thought I'd mention too, don't aspire to build this, for instance. Mirrored backgrounds kind of went out of vogue long time ago. But this was the first example of me building something or trying to solve a problem that I had no idea how to do. CS50 at the time did not teach web programming. CS51 at the time did not teach web programming, did not teach Perl or CSV files or the kind of ingredients I needed to build this, or even HTML or CSS for that. Actually, there was no CSS at that time, or even HTML. And so for me, too, this was an example of being comfortable, being uncomfortable, just volunteering, I will build the Frosh IM's website, and then turning to my roommate and saying, how am I going to build the Frosh IM's website? And just getting comfortable with that idea. You'll figure it out. And honestly, the key secret is to just surround yourself by really smarter people who know way more than you, who are more comfortable than you, so you can stand on their shoulders and learn from them along the way. And indeed, allow me to thank, before we forge ahead, just a few of the folks that you've either seen or not seen, especially those behind the scenes here today, Mike and Luke and Jose and Tom, who with media services have helped us with all of this amazing stuff over the past year. CS50's production team, Dan and Tara and Ian and Andrew, a couple of whom are new this year, and I know they were really thrown into the fire. You see one of them too, Max, the guy who's creepily got a camera on his head today here. Oh, OK, who doesn't at the moment, on our production team as well, all help capture this. And you'll see, too, even this world of video is influenced by software. This other camera here that's just robotically been going back and forth, left to right, all semester, controlled essentially by a PS4 controller via software and via a Wi-Fi connection there, too. So thank you to the team for making possible so many of the experiences you all have had here online. And of course, there's a whole bigger team teaching the class, the CAs and the TFs, our preceptors and the heads of the class, without whom I certainly could not do this. These are all of their names there, sandwiched in. And perhaps if we could, and we'll let them know by playing the video for them, such a round of applause that they got here at lecture as thanks for their time with us this year, if we could. In particular, you might have noticed the notes that are on the course's website, usually a couple days after the lecture. And this is all thanks to a former teaching fellow, Cheng Gong, who graduated a few years ago in computer science and has wonderfully continued to watch the course's videos just a few hours typically after they air, so as to provide you with a canonical set of notes so that you're not yourselves heads down scribbling everything down. Cheng, therefore, is going to be hearing and listening to these very words. And therefore, I've been told to say just what a wonderful person Cheng Gong is, and how we couldn't do the course so well without him, and we really forever appreciate all of his contributions to CS50, and he would make a wonderful addition to any tech company out there. So thank you. Thank you to Cheng as well. And allow me to call out a couple of folks in particular, two of our undergrads who are among the most involved in the course behind the scenes and in front of the scenes, one of whom is in the process of translating the course into Spanish with us so that we can make it available not only to students here, but also natively to folks elsewhere in the world for whom English is a second or not even a third language. And therefore, the English aspects of the class, despite it being open courseware, are just an unnecessary hurdle in terms of the software and the content and so forth. And so, in fact, I thought I'd give you you a glimpse of what CS50's own head CA Veronica has been doing over the past few months. For instance, this is what awaits students online soon as they themselves tackle, just as Zamila helped us here in English, Mario, for instance.
Este problema está basado en el videojuego Super Mario Bros. De Nintendo original. Vamos a dibujar la pirámide sobre la cual Mario tiene que saltar, usando texto para representar los ladrillos. Con esto podemos practicar usando funciones, variables, bucles y mucho más. Cuando estén listos, empecemos.
My thanks to other folks behind the scenes. Some of you might have met Aaron and Greg and Doug, and then one other member of the course's heads who sadly will be graduating this coming spring. Brian Yu literally wandered into my office a few years ago, and we got to chatting about whether he could get involved in some form in the course. And here now, 3 or so years later, has he spent Januaries with us, summers here with us, and pretty much runs the show now. And honestly, of all of the head teaching fellows we've had, all of them are amazing, but there really is something special about Brian Yu. And honestly, in a word, he is extraordinary. And what I thought we'd do is, as thanks to the staff and as an invitation to you all to consider applying to join us as a TF, as a CA, as a photographer, as a producer, any number of hats that the team here wears. We filmed in advance thanks to CS50's production team and thanks to CS50's own Connor Doyle, an undergrad, put together the following film that Brian has beautifully introduced us to. And then we'll take a quick look back at some of our volunteers who have appeared here in lectures past on stage, CS50 Puzzle Day, lunches, and more as a bit of reflection on where you've all come this past year. If we could dim the lights again.
And it's an open door, and off my line of sight once more. You know
Could a round of applause again for the staff. So let's take a quick look back then at what it meant to be 10 weeks ago when we tore, and I was actually just thinking we probably should have added the meme clip to that part of the video here. We tore this phone book in half and began our discussion of computational thinking and all things thereafter. And what we hope to do with this quick look is to just remind you just how far truly you've come and to sort of remind how hopefully a number of these topics have all coincided and intermingled. So this was computer science, right? In week 0, we proposed this black box that we revealed to be algorithms, and we had inputs and outputs. We needed to represent those inputs and outputs, and thus was born zeros and ones and binary. And from there, did we talk about higher level abstractions, talking about how you might have decimal or letters of the alphabet, ASCII and Unicode, the number 65 representing the same there. The same pattern of bits might represent something like a dot or a pixel of yellow. If you have a whole bunch of those dots or pixels, you might have a crying face of joy. And if you might have multiple images like that, you might have animojis or videos more generally. generally, which are just yet another abstraction on top of that. And so as you go out into the real world now after CS50 and see pretty fancy and newfangled technologies, just start to critique them in your mind and consider, well, I know how this feature is done, and I know how that feature implements that feature. Odds are you can reverse engineer in your mind how many of today's technologies work just by building backwards to those lower levels. We then introduced pseudocode so we could talk about what it meant to express yourself more carefully, more methodically, and we introduced loops and conditions and variables and other such tenets that we then translated eventually to another language. And we also talked not about correctness, but about efficiency, so that you have a mental model of just how good your code or your algorithm or your thought ultimately is. And then was introduced Scratch, so that you had a way, albeit graphically, to express all of these various components by programming Scratch up and down and left and right. Of course, things got pretty scary or ugly pretty quickly. We then transitioned to C when all of a sudden the simplest of hello world started to look like that. Odds are that first week, if you'd never seen any programming language before, let alone C, most of those lines did not look familiar except for perhaps the hello world. But even that thing was followed by some random \n, and all of that have we hopefully teased apart over the past many weeks. That, of course, gets compiled down to zeros and ones, which the computer only understands. And thankfully, we humans live in an age where we don't need to worry about that level, or relatively few of us do, because we have abstractions and libraries and other developments on top. In week 2, did we then introduce other aspects of programming and functions and return values and the like. And we also talked about what's really going on underneath the hood. Code like this here, for instance, gets compiled often into multiple files, CS50s, standard IOs, and your own code, and then they all get linked together. But there, too, that's what you're getting for free, so to speak, by running a compiler like Clang, albeit again and again whenever you make a change to your code. We introduced the notion of memory, a little chip that might be in your computer, and if we zoom in on that, it really is just this beautiful, simple canvas of bytes, top to bottom, left to right, that you can do anything you want with. Like, that is it. Despite all of the seeming complexity of a computer, like, that is the canvas that you have to work with. And that was allowing us to do any number of the data structures and algorithms on top of it. For instance, in week 3, we talked about strings. And strings were very straightforward. You might not have heard the word initially in the context of programming, but just a sequence of characters, like a word, a phrase, a sentence, or such. And then things got scary again quickly when we said, those are a little bit of a white lie, an abstraction, more properly, on top of pointers. Of course, pointers themselves got a little scary quickly. And even in retrospect, this might still look scary, and that's fine. The reality is most of you will not have occasion to program in C again. The only occasions I have are generally in September and October of every year myself, because in the real world, I tend not to use this language, though it does remain super popular and super commonly used, especially in hardware-based contexts, where you really want to squeeze as much performance as possible out of the hardware, and you don't necessarily want the overhead of a higher-level language like Python. But what's important is just those principles. The fact that you can put things in memory, you can go there, you can move them. That's all this crazy syntax has been doing for us. Of course, it didn't end well for Binky when you abuse this. And indeed, a lot of today's programming errors, even ones that are still with us today, reduced to misusing or accidentally touching memory that you should not. But once you have that primitive, this ability to stitch things together in memory, then you can start to build things in software, right? We introduced structs in C, which allow us to come up with our own custom data types that have multiple things inside of them. And once you have that, if one of those things is itself a pointer to something else, you can kind of string things together in memory, thereby giving you access to linked lists, which solve problems when it comes to the limitations of arrays. And you can do even fancier things like hash tables that might conceptually and pictorially look like this, or even the crazier trie, which theoretically is even more efficient. It just takes up so much more space. But that's it. With pointers, all you're doing is stitching these data structures together. And even though most languages on top of C, like Python and Java and PHP and Ruby, don't have pointers per se, they have the idea of addresses or references still. So the concept is there. They've just made it a little easier not to shoot yourself in the foot by making mistakes and getting things like segfault. The compilers and the interpreters are increasingly getting good at helping you protect yourself from human error. And then thereafter, we began to transition. Felt like a long time in C, but we began to talk about HTTP and virtual envelopes and messages, just going from point A to point B. And among those things were headers. And you'll recall, perhaps among the more amusing headers was this one. Bought some years ago. If you use a browser, or if you use curl, like a program at the command line in the IDE or your Mac or PC, and you actually request this, what was the status code that came back? Anyone recall? Wasn't 200, wasn't 404? Yeah, it was like permanently redirected. I think 301 or 302 came back, and where did it lead to? Like Yale University. So that was nice and fun. Of course, they bought harvardsucks.org some time ago. And for those unfamiliar, this weekend is, of course, the Harvard-Yale football game here in Cambridge this year. So as clever as Yale has been for like a decade of paying annually for, or rather, as clever as we have been, whoever the alum is, paying for a decade for safetyschool.org, redirecting to yale.edu. Unfortunately, harvardsucks.org also lives on. And in fact, there's a whole wonderful backstory there that was about 12 plus years ago now, where some enterprising students at Yale kind of really got us. Have folks seen or heard this story? So we really embarrassed ourselves some years ago. And it all boiled down to some very enterprising Yale students using a little bit of software and a computer program to create an actual bitmap, like a grid of pixels using humans. The problem was that those humans were us on the Harvard side in the Harvard Stadium, because we essentially created a bitmapped message thanks to their cleverness. So I thought we'd dim the lights and for about 3 minutes look at just how bad they got us. Now, to be fair, we got them for like 12 years or 19 years of football thereafter, though they have been winning the past couple of years, so we can't really talk about this now. So without further ado, let's dim the lights and pull this look up too.
We're headed up to Boston, checking out the stadium for the prank.
A few years ago, I was at a math conference, and I was sitting around at a table at dinner with a few other mathematicians. And one of them went to Harvard and started telling the story of this amazing prank that was, against Harvard. And at that point, I felt I had to interrupt and said, well, actually, I can tell you a lot more about that.
Okay.
The idea was perfected in a dorm room.
Came up with the idea, actually, to prank them with signs at the football game. We threw some ideas out there as far as what the signs would say. We eventually settled on "We suck."
And my immediate reaction was, no, this will never work. However, the problem solver in me started thinking, well, maybe we can make this work.
The problem? They had to infiltrate Harvard Stadium without getting caught, sneak in 1,800 placards, distribute them to unsuspecting Harvard fans, and then convince those fans to prank themselves.
That's great.
We thought about basically every possible thing that could go wrong and tried to come up with a solution for it.
And then you put 2 reds on top of it.
They made fake Harvard IDs and fake backstories, fake placard designs, and a 28-member fake pep squad. On November 20th, 2004, a fake Harvard student smuggled the placards into the game.
What do you think of Yale, sir?
Go. But then, trouble.
What houses?
How many extra are there? Sometimes.
Yeah.
I, just showed him the front of this ID, and all of a sudden he just ran away, and he felt so embarrassed.
Having escaped one confrontation, they couldn't risk another. It was time.
This just looks like a total mess. We have absolutely no idea if this is going to work.
Look at them, they have the paper. It's going to happen. It's actually going to happen. I can't believe this.
What was once a prank became a legend.
And immediately we started hearing chants from the other side, "You suck." And I think it was at that point in time that we knew we had pulled it off.
There it goes again.
I really think it didn't matter that Harvard won because of the prank. For a lot of Yale students and alumni, we definitely won that year.
So there you go, problem solving at Harvard Yale as well. All right, the bar has been set. So thereafter, let's try to somehow make this more academic again. So thereafter, did we transition from looking at the principles of HTTP and the envelopes with which we can send messages, and actually introduced a language with which we can create user interfaces and things far more interesting than terminal windows alone. Of course, there was a connection even to the material past, because underneath the hood, what your browser is doing is reading that HTML top to bottom, left to right, and building really a tree structure in memory that you can then manipulate using JavaScript, yet another language. And then in week 6, did we tragically point out that all that complexity we'd wrestled with just a few weeks ago, trying to build a linked list with null at the end and pointers throughout, actually reduces to just this in Python, just a single line of code. And then this amazing data structure that theoretically has constant time access and dynamic growth because you can chain everything off of it. You just have to write a lot of code to do all of the memory management, is just this in Python. But underneath the hood, that is what Python is doing. In fact, a lot of the Python interpreter, the program called Python, is itself written in C. And so someone, just thankfully not you, has had to write all of that functionality. But Python itself is just an abstraction. These functions are abstractions on top of these lower level implementation details. And that should really become part of your vocabulary, distinguishing between design and abstractions and lower level implementation details, all of which are important, but they don't all need to be at the tip of your mind when you're thinking about how to solve a problem. You can solve problems at this level and then lower down into the implementation details. So after that, we tried to tie everything together, and we looked more generally at web programming. We just looked at one paradigm of web programming, the MVC model, so to speak. There are dozens, probably more these days, all of them with fancy, confusing acronyms. But it's just different ways to solve problem, because we humans, with each passing year, realize that, hey, I and my company and you and your company and you and your dorm are all trying to solve similar ideas. We're all trying to make an app. We're all trying to make a website. And we're all reinventing wheels. And so new frameworks are invented and new methodologies, and people start sharing. And the world starts to collaborate by way of open source tools that we ourselves have used, like Flask being one such example thereof, jQuery a little bit, Bootstrap as well, all of which allow us to sort of solve problems collectively and get real more interesting work done without having to deal with all of those implementation details. And then lastly, did we introduce one last language, SQL, which gave us all the more of a back end, where we can store stuff, a lot more stuff, and a lot more easily than we could with CSVs alone. And if you like this world of statistics and data science and the like, or if you're going back to the world of the humanities or medicine or any number of fields where there's just lots of words, lots of books, lots of text, lots of data ultimately, SQL and all of these languages can be used to help you answer questions that you might have in those domains. So from there, where do we go? So on the, after Thanksgiving break here in Cambridge is the CS50 Hackathon. It will begin at 7 p.m. in the evening, and it will end at 7 a.m. the next night. And it's meant to be one of those uniquely collegiate experiences where you have alongside you all of your friends and classmates and all of the course's staff into the night working on final projects. An opportunity to be productive, an opportunity far enough away from the deadline to feel good about it and to take breaks and to have dinner with us at 9 p.m., to have second dinner with us around 1 a.m., and then if you're still awake around 5 a.m., we charter some Harvard shuttles and take ourselves to IHOP for breakfast as well. But you're welcome to go to sleep at any point in between. Just to give you a sense of what it's like on arrival, do students from both Harvard and Yale ascend the stairs, joining the staff for the evening of programming. We have reserved the entire space above the innovation lab across the river at HBS, where everyone will be able to tuck themselves away into a corner with their partners or with their friends or classmates more generally, and just work throughout the night on their final projects. There's a photo booth and a Zamila as well as other members of the staff. There are therapy dogs in some years if you'd like to take a little break and meet such puppies as these. And then, of course, at 5 a.m. is IHOP. And this is Maria Zlatkova now at Facebook greeting us at last year's breakfast. And then the CS50 Fair. On both campuses is this event, an opportunity for all of you to show off just what you accomplished this semester. Truly meant to be the capstone of what you've done, not exhibiting your own problem sets that you were told how to build, but your own project that you yourself decided how to. We'll invite the entire campus, the faculty, students, and staff from across campus. Usually it's about 2,000 plus people. We'll be in the beautifully renovated Smith Center this year, right in Harvard Square, so we expect to have quite a few passersby and tourists as well. It's always coupled with a fabulous raffle, whereby you'll all be given as student presenters little smiley face stickers or such. Anyone who chats you up and asks you about your project and for a quick demo on your laptop or phone, you'll be able to hand them a sticker and be eligible, therefore, for fabulous prizes. Along the way, though, where there'll be popcorn and snacks and music and more, some of our alumni from industry to talk to you about the real world and summertime and full-time opportunities as well. And what you'll see is a space that looks and feels and sounds rather like this, with folks just mingling around, really proud and happy to see what it is that you and your friends pulled off. with popcorn in attendance, stress balls in attendance, and staff and students alike, hopefully delighting in what it is that you did. Everyone will end the semester with an I Took CS50 t-shirt. Hopefully this is something you too will wear proud. In fact, this truly is where I got my start. 1996, CS50 changed my life. And in fact, here is indeed proof of just how proud I am to have actually gotten my way through this course so long ago when I myself had not had the nerve freshman year even to shop. So hopefully you feel yourselves a member of that community as well. So of course, we thought we'd give you a sense of what the next few weeks might be like, especially if you don't necessarily budget your time properly. A few years ago, we used, before the CS50 IDE, software called CS50 Appliance, which was like a downloadable version of it for your Mac and PC. It tended to be a little slower, and you'll see an allusion to that. But this video, produced by CS50's production team, and particularly Dan Coffey, was CS50's first experimentation with puppetry. And you'll see that we tell the story by proxy of a CS50 student working on their final project just as the deadline nears. And so if we could dim the lights, this will be our last of the videos for today before we now look ahead at the years after. So our thanks to Dan Coffey and the team for producing that as well, if we could. That is indeed exactly how deadlines work. Every time we have a deadline, anyhow, so life after 50. So the training wheels are off. You can keep the rubber duck and have someone to talk to as you wrestle with problems. But the CS50 IDE, while you can keep using it, is not something your odds are going to use in the real world for very long. And there really is no check 50 and help 50 in the real world, though there are lots of humans. They are not called TFs anymore. They're called friends and colleagues, but you can lean on those folks as well. What we thought we'd give you is some list of suggestions for next steps so that you feel like there's offboarding. And honestly, obviously, some of this will happen naturally as you tackle your final projects, depending on the nature. And if you take another class or CS50 Beyond this winter, or you'll experience these things yourselves. But we thought we'd at least give you some links in today's slides so that you have something to tinker with over Thanksgiving or winter break or beyond. So CS50 IDE is meant to be representative of a very common programming environment. It happens to be web-based. It happens to be in our domain name. But this idea of having a file browser of some sort and tabs where you write code and a terminal window with which you interact, incredibly, incredibly common, whether it's in the cloud or more commonly for real-world software developers on your own Mac or your PC. Frankly, some years from now, this will probably be the way it is. None of us use our Mac PCs per se. Everything probably is remotely. So odds are some point in the future we'll come full circle. But for now, it's quite common to replicate this kind of setup on your own Mac or PC. So how do you go about having a command line, which hopefully you've gleaned, while frustrating, is more powerful than only having menus and icons available to you that someone else, like a company like Microsoft or Apple, has given you? Well, in both Macs and PCs, can you install the same tools that we use this semester, Clang and Make, and you get CD and ls and makedir and all of those commands on both Mac OS or Windows, and the starting points can be here. Both of those provide their own sort of terminal windows, and the software therein you can just install via those two starting points. Now, what about Git? You've seen or heard about Git, even though we don't use it hands-on in the class. Odds are you will use this in higher level CS courses if you take it. It's one of the most popular programs with which to save versions of your software. Now, you may have noticed the CS50 IDE does this automatically for you. You can go to File, Revision History, and you can kind of go back and forth in time. And that's great and wonderfully useful, but it doesn't really lend itself to collaborating with others. And so if you're working with partners for the final project, in the simplest form, you can just have one of you share your CS50 IDE with the other usernames, and you'll all just share the same account. And that's fine, but it gets a little annoying and complicated if you're both trying to edit the same files, you're not necessarily talking to one another, and you're in different rooms. Like, at some point, you want it to have good workflows. And so via this URL here, does Brian introduce you to Git, a command line tool that's super, super, super popular these days that lets you save versions of your code. So you no longer call it Mario1.c and Mario2.c and Mario3am.c and the like. You actually call it Mario.c, but you let Git take care of timestamping it and versioning it for you. And Git allows you to share your code in the cloud. What we use GitHub for is for, of course, submissions and such, and for commenting. But more generally, it's used for just storing code and sharing it with other people. So what you'll do with Git is literally Git push it to a service like GitHub or GitLabs or others, where someone else can then Git pull it onto their own Mac or PC, and therefore you're sharing files. You don't email, you don't Dropbox or the like. You actually use a standardized software tool. You can install it via these instructions here if you don't have it already. And more usefully, too, can you sign up for free repositories? GitHub.com, you already have an account. Since you have a student ID, you can go to this URL here and tell them you're a student at Harvard or Yale or beyond, and then say, can I please have free private repos so that you can keep your own personal or school projects private without needing access to CS50's own organization. So what do you write code in? So there's bunches of editors these days. Among the most popular are tools called Atom, which is an open source text editor that has lots and lots of plugins. This is like the tabbed windows for writing code. It does syntax highlighting and so much more, so that your code is easy to edit and it looks pretty while you're working on it and just makes life pretty easy. Also super popular these days is VS Code or Visual Studio Code. They are functionally pretty much equivalent. You can ask your teaching fellows or friends which you prefer, or just try them both. They are free, and there's dozens of other options. These two are just currently have a lot of momentum in industry. Within the terminal window, though, is what a lot of CS students would use, something called Vim. And there's alternatives there called Emacs and a few others. But Vim is actually what I grew up on and still to this day tend to use. I tend not to use a GUI. I just use a bigger terminal window with lots and lots of code inside of it. And Vim is more of a command line tool where you have to memorize keyboard shortcuts more so, but it's also more powerful in the same way a terminal window tends to be as well. So whatever you are most comfortable with is fine. So suppose you want to post a website, like your own personal homepage, your resume, artistic portfolio, or whatnot. Like, where do you even begin? You can certainly make it on your Mac or PC in an HTML file, but no one in the world can access it. You can put it in CS50 IDE, but that goes to sleep eventually when you're not using it, which makes it hard for people on the internet to visit it in the hour. But fortunately, there's so many free services out there, at least if you have modest usage. If you're trying to build a business, odds are you're going to need to pay someone for the bandwidth and the support and so forth. But if you just have a homepage where you're getting dozens, dozens, hundreds, maybe low thousands of visits, which is probably likely the case for personal sites. You can use something called GitHub Pages, a free service where you store your HTML files, JavaScript, and CSS on github.com, and they host it for you for free. Netlify is another free one too, and ... You can Google ad nauseum and find any number of free such services. These just tend to be two popular ones with which I too am familiar. I'm hosting a web app, so not a static website, but it's something more dynamic. We'll have instructions that will circulate for this final project as well, so that you can sort of graduate from CS50 IDE and run your final project or your website or your student group's tool or your startup's website on a third-party service. Heroku tends to be very popular. They too have a free tier of service. So long as your website's not being hammered by lots and lots of users, can use it for free. You get free access to a database, something called Postgres, which we alluded to earlier in the semester, using the same data types we discussed. Wix is another common one too that very recently launched support for code, not just static websites too. So these are starting points, but certainly use Google or the like to find other options as well. Then there's infrastructure as a service, so to speak. There's some bigger fish out there, Amazon and Microsoft and Google, that have cloud-based services. The learning curve tends to be a little higher, frankly. So I would encourage you to maybe start with the previous examples, which are businesses built atop of these layers. But if you're interested, absolutely sign up as a student for any number of these services. And they tend to give you lots of financial credits. So you can just try things for free for like a month or a year or whatnot to get your feet wet. It's a wonderfully free world when you're just getting started in this space. And then more general advice, read lots. And I'm sure if you ask the TFs and CAs, you'll get an even longer list of sites. But these tend to be the kinds of sites I go to if I just kind of want to stay in the loop on things. Subscribing to various subreddits, so to speak, is compelling, where information, news, conversations just get pushed at you. And honestly, whenever I'm asked how I kind of stay in touch with certain things, I hear things from friends. I get emails about technologies. I get curious, and so I poke around. And these tend to be the places that I might go, and a lot of tech people go, to talk about new trends and technologies. Or if you're trying to vet something, should I use X or should I use Y? Don't just use Google. Check out those websites as well. And then CS50, if you'd like to stay in touch. So CS50, not so much here on campus, but for students around the world, maintains a number of online communities, all of which you're welcome to partake in, answering questions or asking questions or the like. And those are just the few of the current one nows. Any questions on any or all of those past or future steps? Anything at all? No? All right. Is that no? No? OK, so we'll adjourn in just a little bit time for our tradition of cake downstairs in the pub. But we also have one other tradition, especially now that you have some 10 weeks of experience behind you. For all intents and purposes, you are all now qualified as CS50 staff because, indeed, at the end of the day, most of CS50 staff are recent alumni of the course themselves. Sophomores, juniors, senior, recent graduates, students online who have taken this class, maybe taken another class in the spring or beyond, and then join us as staff. So realize that even if you're not feeling more comfortable yet or most comfortable, nor are most of the staff and myself included with a lot of these things. And so long as you stay one step ahead and you know the kinds of resources to turn to, this is what it really is about when learning in this world. And in fact, a very common mindset I do know in the class, in the problem sets, in the quiz is, wait a minute, you didn't teach us this. And that, odds are, was quite true quite often. And I don't just mean to be rationalizing it. Like, that was very much by design. Like, in the real world, that's exactly the emotion you're hopefully going to feel or realistically going to feel quite often. And we truly do hope that among the tools you've gotten, training wheels and beyond, is to know or to have the right instincts now with how to bootstrap yourself, so to speak, and solve problems and learn things on your own. But we thought we would, in conclusion, put that to the test. And I think for this we need, so let's say if we have a bunch of chairs up here, 4 student volunteers. 4 about to be alumni volunteers. OK, over here in the front. Yeah, come on down. Over here in the front, and 3. And let me try to see about 4 over here. Come on down. All right, 4. Well, you have 4. Yeah, Colton's going to join us. Uh-oh. OK, we'll take 5. That's fine. But you got to bring a chair. We'll find a chair somewhere. Come on down. And now I need 4 staff volunteers, if we could. Who on the staff might yes. Ma'am, come on up. Athena has volunteered. Oh, Aaron, would you like to come? Oh, come on. Yeah, yeah. Who? OK, yeah, come on up, Robert. OK, thank you so much for volunteering. OK, so, but the catch is we need the staff on their own team. So that's let's put the students here, because you need, that's OK. Could you guys go over here? OK. All 5 of you. We have our student team over here. And we'll find you one more chair in just a moment. Staff, go ahead and take a seat here. You each have a piece of paper, a pen, and a microphone. And why don't we go ahead as we get ready to go here. Do you want to each just say hello and introduce yourself?
Hello,
But you can hold it. Okay.
Hello, I'm Aaron, one of the course preceptors.
I'm Isaac, I'm a TF.
I'm Robert, I'm a CA.
And I'm Athena, I'm a TF.
Hi, I'm Andrea. I'm an alumni soon. Hi, I'm Aviva. Me too.
I'm Jonathan.
I'm April.
I'm Eric.
Hi, I'm Colton. I'm a technologist.
All right, so what are we all doing up here, you might wonder? Well, we have this tradition of using all of those questions that you offered for the quiz. Recall in problem set 7 just a couple of weeks ago as refreshers. Now, mind you, there is quite the difference between, I think, a lot of the questions you offered up as suggestions for quiz questions. Many of them were like, what is 2 in binary? Or maybe what is 3 in binary? And so that was great, but we were looking for a little harder questions. And we did get some of those too. And so Colton kindly went through the thousands of questions that were submitted just a couple of weeks ago to pluck out some of the most serious, some of the most playful ones. And I have here them clustered into categories because we have this tradition of playing our own version, staff versus students, of Jeopardy. Now, because you all wrote the questions in the form of questions, I'm going to read them in the form of questions and not answers. So it's more of a quiz show if we could. Staff versus students. The first person to raise their hand we'll call on first. We don't have buzzer technology here. Colton will be our judge, if you don't mind being the judge. And we'll do just a few rounds of single and double and then end on Final Jeopardy followed by cake. So in a moment, we'll show you the categories and begin asking the questions. Do you have any questions of your own?
Are we answering in questions?
You will be answering as an answer. I'll ask the questions, you answer. So it's not really Jeopardy, but it just kind of sounds better if we call it Jeopardy. Okay. Okay, so, and also, look at what we made in HTML to facilitate this. Let's zoom in. Here we go, enhance. Ooh, look at those HTML tables and links. OK, so without further ado, I think before today began, we decided that the students had won the coin toss. Would you like to pick a category? And then I'll ask you a question in that category.
Scratch for 1,000.
Scratch? For what, $100? No.
There's no 100.
1,000.
Oh, 200. Oh, I heard 1,000.
Yeah, 1,000.
OK, so week 0. Week 0, the question is, what institution developed Scratch?
Oh.
Colton?
They got it.
Nope.
Are we doing it where
Yeah, whoever raises their hand first.
I saw hands here. So.
OK. OK, students?
MIT.
MIT is the correct answer for 1,000 points. Very nicely done. OK, if no one's going to clap. There we go. No, it's OK. We have an HTML button for that, too. All right, so students, you have control. What would you like?
Scratch for 800.
Yeah, I was just
Scratch for what?
On the scratch ones.
Scratch for 800.
Scratch for 800, working our way through the scratch questions. OK, what color is the cat? Students.
Orange.
OK, orange. Now, funny enough, 2 people asked this question in PSET 7, and we got 2 answers. Yellow and orange. Perhaps by a show of hands, yellow? Orange. OK, orange. Students get the $800. Very nicely done. Students?
We should do something big.
Don't do I'm terrible with
Arrays.
No. Fine.
Fine, arrays.
Arrays for 1,000?
Arrays for 1,000. So this is from week 2 for 1,000. This is going to be, what is the running time of merge sort? Staff?
And log n.
And log n is correct for 1,000.
One question, the whole thing.
Staff, what would you like?
Arrays.
Memory.
Memory for?
1,000.
For 1,000?
Yep.
OK. For 1,000, what is the name of the tool you can run to see if your program... Staff.
Valgrind.
If your program has memory leaks, Valgrind is correct for 1,000.
If your program has a compiler.
Yeah, I know, right?
Nice.
Staff for 1,000. What do you want next?
Weak star.
Oh, and weak star is the wild card, so you can get any week.
This is weak stuff.
Weak star for 1,000.
Weak star for 1,000. So I shall choose the category to be... What is rubber duck debugging? What is rubber duck debugging? Students.
I'll answer it. It's when you read every line of code to a rubber duck and to try and find a mistake.
I think that's correct. Very well done for 1,000. All right, I think we have time for one more question in single Jeopardy. Students, you have control and the lead.
Go for the lowest possible.
Why don't why don't we try and read for 800 or C for
like 200 because then they can't catch up.
Yeah.
C for
Yeah,
200?
no, you're good. Yeah.
Students?
C for 200.
C
C for 200.
For what?
C for 200.
C for, whoa, OK. C for 200 in week 1. Week 1. Your question is going to be, is C the absolute worst? Students for 200?
Yes.
No, okay. I think it's not because the person asking that would say yes. So we just have to match their answer.
Wait, we have to match their answer? Or do
Yeah, the correct answers are right here.
I can't say yes.
No. This is what I'm told.
Say yes.
Yes.
I hear 2 yeses and 1 no.
So
I stick by my
majority
opinion.
wins.
The answer is yes, it is the worst. For 200. OK, so we're now moving on to double Jeopardy, where all the dollar values are doubled and the categories have changed to later weeks, still with 1 wild card. Students.
Oh God. Python for 2,000.
For 2,000.
I'm sorry, I just made that decision fast.
Python 2000.
What week?
Python 2000.
Python for 2,000. So that's week 6. Python for 2,000. And a question that a classmate asked was, what is an animal that you don't want to find under your pillow that shares its name with a programming language? Students.
Python snake. A python snake.
Python is correct. Yes, for $2,000. Very nice. Students.
Python 6.
Time for just a few questions before we move on to final.
Oh, let's do like web. Do you guys want to do web?
Yeah, sure. Web.
Web for 2,000.
Web for 2,000. That was week 7. And a question here was, who is your friend?
What?
Students for 2,000. Oh, did you see Aaron first? Sorry, Colton's the judge.
Developer tools?
I'm sorry, that's incorrect. Yes, students?
Expect element.
Inspect.
Inspect element.
Inspect element also incorrect, I'm afraid. Students again?
A rubber duck.
A rubber duck is incorrect.
Google.
Google, no. I think you're negative 8,000 now, but that's OK. We won't deduct. We won't deduct. It's fine. I know that's not how Jeopardy's played. OK.
W3 schools.
W3 schools, incorrect. Students? What?
David Malin.
No, not him. Yeah?
Stack Exchange.
What's that?
Stack Exchange.
Not Stack Exchange. The answer is Bootstrap. I don't know. OK, moving on. So time for 2 more questions in double Jeopardy. Students, I think, had control, right?
What do you guys want to do? Week for 2,000.
Staff need to pull ahead here.
Yeah, just like anything. 2000. Wild card 2000.
Week for 2,000.
What?
Wild card 2000.
Wild card for 2,000. Audience, what week shall we give them? 1 through 7? 0 through 7? 4, I heard. Week 4. Week 4. What is the code for OK? Staff.
200.
200 for 2,000. All right. So staff have control. We have time for one more question before we move on to Final Jeopardy.
Oh, you, Isaac, it's all you.
No, we want to be able to like be in touch with it, right? Okay. Data structures, 1,200.
Data structures for 1,200. Data structures for 1,200. And that was, what week is that? 4. That's week 4. What do you call the situation when a structure refers to itself in its definition? Students.
Recursion.
Recursion is correct for $1,200. Very nice. OK. So we now go into our last question of CS50 of staff versus students. Staff have 4,000. Students have 6,200. You're about to be told the Final Jeopardy category, at which point each team needs to commit in writing on the sheet of paper in front of them with the CS50 pen in front of them to a dollar amount, keeping in mind that you will either gain or lose this amount. All right. Go ahead and choose your, oh, here we go. The category for Final Jeopardy is going to be buggy. Buggy will be your category. Any dollar amount. Any dollar amount. OK, so here we go. The question is, they've all committed to a dollar amount. OK. I feel like you can hedge your bets there. All right. So here we go. Final Jeopardy. Buggy is the category. In which state, besides Massachusetts, does Google sometimes think we reside? In which state, besides Massachusetts, does Google sometimes think we reside? All right. So I think staff were not in the lead, so we start with you. Staff, first of all, how much did you wager? OK, depending, I think, on how the question went, they wagered either $4,000 or $40, apparently.
Floating point error.
40, we'll go with 4,000. And what was your answer?
We picked Kansas.
Kansas. Interesting. Now, students, how much did you wager?
2,000.
2,000. And what was your answer?
Also Kansas.
And also Kansas. So 2,000 would bring you to 8,200. 4,000 would bring you to 8,000. So if you're both right, students, you might have clinched it. Does the audience remember where Google thought we were a few weeks ago, despite the fact that I misstated where Google thinks we were? Oklahoma was my incorrect answer, it turns out. Wyoming also incorrect, but we can do sort of binary search in that area. Anyone at all? It is, in fact, Kansas, so congratulations to the students team. A round of applause, if we could, for our students. Thank you so much for joining us in CS50. We are so proud of you all. Cannot wait to see you at the fair. Cake is now served downstairs, and my thanks again to the staff.